In this video, I'll be applying the mesh or loop analysis. To solve the problems related to AC networks having inductor, capacitor or resistor and AC source. So I'm taking a simple circuit. The circuit has been formulated by me, so you can cross check the result if it is coming correctly or not. I'm taking a simple circuit because circuits involving the AC components are larger to solve. So if you take a simple circuit and if you have 10 ohm and 10 ohm and J10, which is the inductive reactance, so and the supply is 100 with the phase voltage of the phase angle of 0. So this is my circuit and my task is to find I1 and I2. So I take two loops, which is I1 and I2 current. So for loop 1, if I apply the KCL or KVL, the equation will be minus 100 with 0 degree plus 10 I1 plus 10 into I1 minus I2, which is equal to 0, and minus 100 with a voltage of the phase angle 0 can be resolved as 100 cos 90 cos 0 plus j of 100 sin 0. This will come to 100 itself. So this is minus 100 plus 10 I1 plus 10 I1 minus 10 I2 is equal to 0, is equal to minus 100 plus 20 I1 minus 10 I2 is equal to 0, which is equal to minus 10 plus 2 I1 minus I2, which is equal to 0. So my I2 is equal to minus of 2 I1 plus 10. Again, it's possible to solve this in multiple ways. So it's possible to solve this same problem using both substitution and Cramer's method. If I'm using Cramer's method, this will be my first equation, and if to find out the second equation, if I apply to the second loop, it will be 10 I2 minus I1 plus j of 10 I2 is equal to 0. So 10 I2 minus 10 I1 plus j of 10 I2 is equal to 0, which can be found out as 10 plus j10 I2 minus 10 I1 is equal to 0. If I'm simplifying it, it can be minus I1 plus 1 plus j of I2 equal to 0. If I'm writing this in matrix, the two equation, which is 1 and 2, then this can be written in the matrix form as uh, 2 and minus 1 and minus 1 and 1 plus j. So again this will come as 10 and 0. So my delta is equal to, based on this coefficient matrix, it is 2 into 1 plus j plus or minus 1 is equal to 2 plus 2j minus 1, which is equal to, my delta is equal to 1 plus 2j. And if I'm resolving this, it will come close to what is 2.23, making an angle of 63.43 degree. How I got this is, I got this by taking this as x and y, and my z is equal to under root x square plus y square, and my theta is equal to tan inverse of y by x. So that's how I got this. And if I am taking my delta 1, then that will be equal to this matrix for finding the I1, 10 0 minus 1 of 1 plus j. So my delta 1 is equal to 10 into 1 plus j, which is equal to 10 plus 10j. So my delta is equal, delta 1 comes close to, if I am resolving it, it will come close to 14.14, making an angle of 45 degrees. So my I1 is equal to delta 1 divided by delta, which is equal to 14.14 divided by 2.23, making an angle of 45 degree, and here making an angle of 63.43 degree. So I am dividing this, it will be close to what is 6.34, and making an angle of 45 degree minus 63.43 degree. I divided this and taking subtraction, so it is 6.34, making an angle of minus 18.43. So this is how I can find my I1 based on my delta 1, and if I write it here, my I1 is equal to 6.34 to minus 18.43. Similarly, if I find my delta 2, if I can directly write here, it will be equal to, if I have to replace 10 and 0 here, so it is equal to plus of 10. So my I2 is equal to delta 2, which is 10, divided by 14 point, or 10 divided by 2.23, making an angle of 63.43, which comes out to be close to, my I2 is equal to, comes out close to be 4.48, making an angle of 63 of minus. So my I2 is equal to 4.48, making an angle of 63.43 of minus. So this is my I1 and I2, and this is how to apply the loop analysis to a AC circuit, and this is how you can solve it. At the same time, if there was a capacitor here, if I was replacing this by a capacitor, then it would have been minus J10 here if the same value of the capacitor. So inductors are having positive J, at the same time capacitors are written by minus, and if there was a different voltage like a 30 or 5 degree or 45 degree, then it would have been resolved as 100 of sine cos 45 plus j sine 45, in that way. So that's how to solve the circuit